Hello, Math 1. We're back with Lesson 6 of Remote Learning. Today I'm going to show you guys what I think is a nice little interesting segue lesson before our next step in the factoring ladder. We talked about prime factorization, which led us into greatest common factor, which then we talked about our first polynomials review, which was basically talking about how the distributive property works. Then we saw that factoring is actually the reverse of the distributive property. This is going to take itself to another level after we talk about this polynomials multiplication review. So what you should be thinking as you do this lesson, it's 5 questions, it'll be a really quick, easy lesson, is how does this work its way into factoring? Because factoring is going to be the reverse of the distributive property, okay? But right now, this is just a review lesson, so let's get to it. All right, so the first thing I'm going to do is erase this first polynomial and write it in a different color. We'll have red to be the first polynomial, multiplied by black the second polynomial. And what we talked about was the distributive property states that everybody in the red group is going to be multiplied by all parts in the black ink group. So what I showed you guys last month was that we can literally rewrite this 2x side by side with the 4x minus 5. When we write it there, it's like, oh yeah, we're multiplying when you put something on the outside of parentheses to something else. We're going to do the exact same thing with the negative 3. So that negative 3 comes down here, times 4x minus 5. From there, it's just applying the distributive property that we talked about in that first polynomials review. So you're going to get 2x times 4x, which is 2 times 4, 8. X times x, that's x to the second power. Then you're going to take 2x times negative 5, and you're going to get negative 10x. And then on the second group, you're going to have a negative 3 times negative, or positive 4x. You'll get negative 12. Don't forget to tag along that x there. And then you'll take negative 3 times negative 5. That'll give you a positive 15. Okay, from there, all we do is combine like terms. These two go together. So negative 10 minus 12 is negative 22. Make sure that they get an x. Remember, when you add or subtract, you do not change kind of like the identity of the variable. If it's an x, it stays an x. If it's a y squared, it stays a y squared. Don't forget to bring down the 8x squared and the plus 15. All right, so our first example, super simple. Moving on to the next one. Now, you might have the urge to take that little 2 right there, that little square, and distribute it to both the 5 and the x. That would be a bad move, though, because this does not equal x squared plus 5 squared, which is 25. It actually doesn't equal that. Here's why. When you see something taken to the second power, it just means rewrite this twice. It's the thing multiplied by itself that's given the square power. So I'm just going to rewrite it twice. In fact, I'm going to rewrite 1 in red and 1 in black. Why? Because now it looks exactly like number 1. So no problem there. This red x is going to be multiplied by black x plus 5. This red 5 is going to be multiplied the black x plus 5. Okay. You guys could probably pause it and work it out yourself to see if you got the right idea. X times x is x squared. X times 5 is 5x. 5 times x is 5x. And then 5 times 5 is positive 25. Now you have elements of the incorrect version there. You have some elements of the x squared here and the 25 at the tail end. But there's a 10x in the middle, and you miss that when you just try to distribute the square. All right, so far this is looking good. Moving on to the third example. All we have that's different here is that there are more than 2 terms inside here. I'll rewrite this so you can see it, and I will quite handily do one in red and one in black. X squared plus 1x minus 2 times 2x minus 5. Yeah, there is no difference between what you do in this problem and what you did in the first 2 exercises. In this one, you're just basically saying red x squared times black 2x minus 5. Positive 1x times black 2x minus 5. Red negative 2 times black 2x minus 5. So why don't you just pause the video, work it out on your own. All right, so what we have here is 2x cubed minus 5x squared. 1 times 2 is 2. X times x is x squared. This is negative 5 times 1. Make sure you put the x's on there. I can't tell you how many times I see people forget to distribute the x to the constant part. So just be on the lookout for that error. And you get negative 4x plus 10. Remember, distribute that negative to both parts. Combine the like terms where you can. So 2x cubed, a negative 5 plus 2 is negative 3. X squared, and then a negative 5 minus 4 is negative 9. Keeps the x, and then plus 10. All right, and the last one, just for kicks, is number 4. You've got a 3-term polynomial times another 3-term polynomial. Yeah, pause it again and see if you can work it out on your own. All right, now I'm going to show you something that's maybe a different way of organizing your work than what we had before. So I'll write it larger so that everybody on YouTube can see it better. Again, you should be looking at your notes that's attached to Google Classroom. We can technically just sort of visualize the different groups by saying, hey, cover everything up. What do you got? X squared times x squared minus 4x minus 2. So you can just kind of visualize it that way. You don't need to rewrite everything. I think rewriting helps at the start, but again, we're reviewing this. So x squared times x squared is x to the 4 power. X squared times negative 4x is negative 4x cubed. X squared times negative 2 is negative 2x squared. And then you're done with the first part. Now this is where I like to take an interesting approach. I like to say, all right, that negative x is going to be multiplied by the x squared minus 4x minus 2. But instead of putting it side by side with it, I'm going to instantly stack it with its like terms. So if you think about negative x times x squared, that's negative x to the 3rd power. I am literally going to write negative x to the 3rd power right below negative 4x cubed. So then I can instantly just be like, hey, I got negative 4 minus 1. I know I have, at this point in the problem, negative 5x cubed. And I'll continue to do that with the rest. So then a negative x times a negative 4x, make that positive 4x squared. And then a negative x times negative 2, we just have to create a new column here. So we're going to call it plus 2x. Yeah. And then do it with the last term. So you get positive 1 times everything. Positive 1 times anything just rewrites it. So I have 1x squared minus 4x minus 2. Because everything's being multiplied by positive 1. Leaves it unchanged. So then we add it. It's conveniently stacked with our like terms in descending order. It'll be a polynomial in standard form right away. All right, so then we had negative 2 plus 4 is 2. Plus 1 is positive 3. And then 2 minus 4 is negative 2. And I'm putting the variables on the tail end just like we normally do. All right, now I just wanted to show a side-by-side comparison on this last example. It's really not going to come into play too much with the whole factoring game, but I think it's good enough. It's a good idea to review it. So let's say we have two things that almost look exactly alike. Almost. This one has identical polynomials separated by a minus. Okay? Identical polynomials separated by a minus. This one has identical polynomials separated by nothing. But when they're separated by nothing, when they're just put side by side with one another, it's implied that it's multiplication. So what you have to train your brain to do is to say, this one means I'm creating those 2 or 3 different levels where the multiplication actually happens. See, this is x squared plus x cubed. Okay? When I take the first times these two. This is plus 2x cubed plus 2x to the 4. Okay? And this is minus 3x. So I'm actually going to move this way. Minus 3x minus 3x squared. Yeah. That's what this one becomes. So it's 2x to the 4 plus 3x cubed. There's a 1 there. Minus 2x squared minus 3x. There'd be a plus here. So there's the product of our first. This one's basically saying, hey, I'm not multiplying these things together. There's an invisible 1 out front here, and there's like a negative 1 out front here. I'm just distributing a 1 to my first group of polynomials, which just means nothing changes inside. And then I'm distributing a negative 1 to the second group of polynomials, which just makes all the parts negative. Then we just combine like terms. So you get 2x squared minus 1x squared, which is positive 1x squared. X minus 1x, well, those two cancel each other out. And then there's a minus 3. So two very, very different answers between subtracting two polynomials and multiplying. So just don't fall into the trap of, I don't know, I see students sometimes where they'll distribute the negative 1 right here. Then they'll multiply everything. So they'll take these groups and try to multiply them together. But clearly that's not what you're supposed to do. All right, you guys got 5 exercises. All right, 5 exercises. I'm trying to figure out how many people are actually watching these videos. So I don't know, if you could just when you submit your answers into Google Classroom, just tell me, hey, I watched the video. All right. Thanks, guys. See you in a bit.